Well, good morning, RH students. Hope all is well. Do me a favor and go on the website and please print out the next set of notes. It has today's date on it. And then it says, what are the roots? And that's going to be our kind of keyword of the day. What are the roots of a quadratic function? So I'm going to give you a second. If you have not done so already, pause that video and please go print this out and follow along. All right, so our do now is a recap of yesterday's lesson. All I would like you to do is we're going to make a table of values for 4 different looking quadratic functions, and then we're going to get into our new lesson. So what you could do right now is you could actually pause the video and start to answer these 4 questions, and then replay the video, and we'll go through the solutions together. All right. All right, so the first thing you always want to find is the negative b over 2a value. What that's going to give you is it's going to give you the x value of the vertex. So in this case, we're going to get negative 2 over 2 times 1, so x equals negative 1. So that's going to be our middle value. And again, once you have that middle value, you're going to fill in 3 on either side of it. The reason you want points on either side of the vertex or the turning point is so that you can actually see both sides of this parabola. So go ahead now and fill this in. This is going to be negative 1, and then we're going to get larger, and we're going to get smaller. So we're going to go from negative 4 all the way to 2. Remember, this is not a restricted domain question. These are just the x values we're choosing to use. I'm going to go ahead and fill in all of the x and y values for this table. Again, plug this into your calculator and you can easily get those values. So 5, 0, negative 3, negative 4, negative 3, 0, and 5. Once you have those values, all I want you to do is plot each of these input-output pairs, and we're going to see that it actually starts to look like a U-shape, or in other words, a parabola. So again, y-axis, x-axis, we're labeling. We're doing all the same work we would do for any function that's linear or exponential, or in this case, quadratic. And so I'm going to start plotting these points. All right, now just a reminder, do not go too much past that last point. Otherwise, you'll end up shooting it off in a direction that you don't want it to go. So now we're going to curve and bend this one up just a little bit past it, or maybe not even at all. And we are going to stop our parabola there. Last thing we want to do is we want to label with the equation y equals x squared plus 2x minus 3, just like we always do. All right, so if you didn't know what to do before, now go ahead and just keep going with those other 3. If you already did, feel free just to watch the rest of this video and just watch how these get formed as well. So we're going to locate x equals negative b over 2a. So in this case, we're going to have 6 over 2 times 1, which is going to give us a value of 3. So 3, 0 is going to be our answer for our vertex. Again, these are our key points. That is where this parabola will turn. All right? So 3, 0, and then I'm going to just fill this in from the calculator. 0, 9, 1, 4, 2, 1, 4, 1, 5, 4, and 6, 9. All right, so we're all set here. So let us just graph these points quickly on this one, and we'll get this shape here. So we have 0, 9, 1, 2, 3, 1, 4, 2, 1, 3, 0, 4, 1, 5, 4, and 6 all the way to 9. And so our parabola is going to open up. I'm going to label it with the y equals equation. Y equals x squared minus 6x plus 9. Awesome. We're going to keep going now. This one's a little bit different because you realize it's missing the b term. So let's just show what happens here when we go to find our turning point. So x equals negative b over 2a. I'll just write that down. So it's going to be 0 over 2 times 1, which is 0. Again, if there's no b value, we're going to put in a 0 for that. So 0, and that's going to be with 3 from the calculator. Again, just keep putting these in your y equals in your calculator. You get all these values. Let's just put a couple points here that we can actually fit. Negative 2, 7. I can't fit anymore, so I'm not even going to put them in the table of values. And then 2, 7. This point is called the vertex or the turning point. So I'm going to do that one down here in this kind of bottom third one. So let's label this as our y-axis and our x-axis. So negative 2, 7. Negative 1, 4. 0, 3, 1, 4, and 2, 7. So we're going to have a parabola kind of right up here. Do the best you can to make this a smooth curve. This should not be, they should not look like straight lines. They should be curving as you go up here. And then we'll label with the equation y equals x squared plus 3. All right, awesome. We are making good progress. We have one more to do. So let's find our negative b over 2a. So that's going to be negative 4 over 2 times 1. And that's going to give us a value of negative 2. So negative 2 comma negative 6. That is our turning point. You don't have to box these in. I'm just doing that to keep showing you that we need some points on either side of where this turns. Otherwise, we'll only get half of the parabola. So again, going to my calculator's table of values, I'm just going to find a bunch of input-output pairs. So negative 5, 3, negative 4, negative 2, negative 3, negative 5, negative 1, negative 5, 0, negative 2, and 1, 3. And I'm going to put this, these are my XYs, my input outputs. I'm going to put these in this bottom right graph down here. So let's plot those together. If you haven't done so already, we have negative 5. And then we're going to go up to 3. Negative 4, negative 2, negative 3, negative 5, negative 2, negative 6, negative 1, negative 5, 0, negative 2, and 1, comma 3. So there's our parabola. We're going to label that with our equation, y equals x squared plus 4x minus 2. All right, awesome. So here's what we're going to do. We're going to take these four graphs and we're going to answer this question, what are the roots of a quadratic function? So go ahead and flip to the next page and we're just going to take a look at this. All right. So my first question is, well, here's all the four from the do now. These are the four we just graphed. All I want to do is just look at what the x-intercepts are. So let's put this back here. So take a look here. X-intercepts are where any graph crosses the x-axis. So where does this first graph cross the x-axis? Well, it crosses at negative 3 and positive 1. So let's just write that down. Negative 3 and positive 1. Let's go to the next one. What we notice about this one is it crosses at only one location, at 3. We would say that this is tangent to the x-axis. It kind of bounces off at one location. So what we're going to do is just write the number 3 here. And then what we have is this guy here. This actually does not cross the x-axis at all. So we are going to say none. And the last one here, this one looks like it is going through at different decimal places. So this one is in between -4 and -5. So somewhere in between -4 and -5. Let's say between. And the other root is in between 0 and 1. So let's put between 0 and 1. All right.